So hi guys, welcome back to my channel. So today we are going to learn about the builder pattern, and I know I have taken a long gap in order to upload any of the videos in my YouTube channel. So I've started with the creational design pattern, and this is the third pattern that I'm going to explain now. So this coming week I'll be uploading all the creational design patterns that I'll promise. Okay, so let's start the builder pattern. So before explaining the builder pattern, I'll tell you one thing. If you would have worked on this Spring Boot, any of the project, you must have seen the @builder annotation. Okay, inside the entity you must have seen @builder. Okay, the implementation of that builder inside the Spring Boot, this annotation, it's same here what we're going to see in this video. So just for you all to build the interest, I have told that okay, this is the real life scenario that you'll be using in your project, and in this video we are going to see the inner implementation, how builder pattern is built. Okay, so let's see. It is a creational design pattern that separates the construction of complex object from its representation and allowing the same construction process to create different representation. Okay, just bear with me till the end, and at last I guarantee you that the builder pattern never will tease you anymore. Why it is introduced? The problem it solves is telescoping constructor. So the problem it solves is telescoping constructor. Before builder pattern, the developer used to overload constructors just like this. Okay, now the problem is, in this way we are passing the fields values like we don't know which parameter is for which field. And the main problem is, if we want to pass only 3 fields out of the 10 fields, you still pass, or you still have to pass null values in the 7 fields. Okay, so this is the major problem, and adding a new field breaks every constructor calls. Let's say in a constructor, while defining a constructor, you have decided that you'll be having 5 fields inside the constructor, but let's say there is a requirement in which you need to have 6 fields or 7 fields. Okay, then your constructor will end broken. So in order to solve this problem, this third problem, what developer used to do is they initialize the constructor in every possible way they can. Okay, let's say we have 7 fields. Okay, so all the combination of 7 fields, every possible combination, they make the constructor in order to set the field values. Okay, I hope this is clear, and this is a very cumbersome process till now, until the builder pattern was introduced. Now let's see how builder pattern actually works and what is actually the builder pattern. Okay, so builder pattern was introduced to eliminate the telescoping constructor. Okay, allowing step-by-step object creation, support different representation from the same process, and make constructor readable and maintainable and safe. Okay, I hope this is just for the definition. Okay, so this is the theoretical part. Now let me directly move you to the code, and then we'll see the code internal flow. These all the internal flow that I have made for you all, and some of the important questions that still be in your mind. I know that will be the genuine questions that will be in your mind after I'll explain the code, how it is work. Let's see the code. Okay, so in this code, what I have done, class pizza, I have declared a class pizza, and these are some instance variables I have declared inside the pizza class. Okay, this is the constructor, a normal constructor. Let's say I have 5 fields, so 5 initialization I am doing, or setting the 5 fields inside the constructor. This is very simple till now. The static factory method, this is the game changer. Okay, this is the static method of this pizza class. Okay, this is the static method of the pizza class, and this is the override of the toString. Like this is just for the printing of the pizza class, like whatever fields we have. Okay, now here comes the main crux of this builder pattern. Inside the pizza class, if you'll see, I have declared a public static class builder. Okay, the same implementation will be used inside that Spring Boot project where you all will be very frequently using the @builder pattern. Okay, so inside the builder pattern, what I have done, private final string size, this is the final method that I have declared. Like if you once have initialized this size, you are no longer be able to change this field. Okay, and rest of the some default fields inside the builder pattern. Just wait for a few seconds how this code is working, entire flow, everything will be clear. Okay, inside the builder class, I have declared one constructor, again one constructor, and some of the getter and setter methods. I'll not say actually the getter and setter methods, I'll say the setter of some of the fields. Okay, now moving to the main code, which is public class pizza builder. Pizza is equals to pizza.builder. We are passing the size as large. Pizza.builder. Let's go to the method. Okay, here if you would have noticed that pizza class have the builder method. Okay, this. So pizza.builder passing size as large. It will return me a new builder. Just remember, it will return me a new builder with size as large. Okay, new builder. Now comes to this class, public static class builder. This builder constructor is getting called. Okay, where is the constructor? If you'll see here, this is the constructor builder, and it is taking the parameter as string size. Remember, we have passed this size as large here. Okay, in this we have passed as large. Okay, till now I hope this is clear. Now inside the constructor, when we have passed the size as large, this set this dot size is equals to size, means the size is set as large. Now moving next, what this pizza dot builder returns to us is a new builder object. Okay, if you'll see here, it is returning a new builder object. I hope this is getting clear. So it is returning in the builder object, and the builder constructor is getting called. It will take the size of the pizza and it will initialize the size of the pizza as large. Okay, till now this is clear. Now as soon as this part will return the new builder object, and post that we call the crust. Let me remove this. If you'll see here, this part is returning a new builder object. Okay, by setting the size as large. Okay, till now we are actually playing with the builder object. Okay, pizza dot builder, it is returning a builder object with size setting as large. I want to repeat it again and again so that it gets in your muscle memory. Okay, now whenever it sets the size as large, it is returning a new builder object, and on that builder object we are calling dot crust stuffed. Now let's see what this happens. We have called on that builder object, we have called crust method with string crust as stuffed. This dot crust is equals to stuffed. Now you'll see thin, default was thin, we have sent it to stuffed. Okay, size as large. I hope this is clear. Till now this is clear. Now what is this? Return this. Okay, what the actual agenda of returning this? Now what will happen? Inside the pizza dot builder, we have returned a new builder object, so that we'll be able to call the dot crust inside that object. Okay, but what about that crust? We again need to call this cheese, pepperoni, mushrooms, but on what object we need to call this? Okay, so return this means this keyword is used to represent the current object. So this represents the current object, and when we call this public builder crust, remember this, the type is builder. Okay, so crust is returning the same object builder. Okay, I hope this is clear. This is returning a new builder, as we have seen above that this is returning a new builder. Now just because we have called this crust, which is having stuffed, what it has done, it has set the field as stuffed and return this means the same builder. Okay, here if you'll see, the same builder object is returned. And on that same builder object, the cheese is called. Okay, let's see. On that same builder object, this cheese is called, and inside that this dot cheese we have passed true. Okay, we have set true. So what we'll do? We'll set the cheese as true. Okay, so again we are returning this. This means the current object which is pointing to. Okay, again we are returning the builder. Okay, now what will happen? Cheese will also return the builder. Okay, now on that builder object, again the pepperoni is called. Inside that pepperoni, this dot pepperoni is equals to true. What we'll do? We'll set the field as true. And again we are returning this. This is pointing to the current object, so that the builder object is again getting returned. So inside that pepperoni, again we are getting returned as builder object. That same builder object we are pointing. Okay, now till now we are playing on the builder object. Now this dot builder dot build. Now where the call goes. Okay, builder, let me show you this builder dot build. Can you see this build? In that build, what it is going to return, it returns me a new pizza, and inside the parameter we are passing this. This means again we are passing a builder object, complete builder object. Okay, because we have called the build on that builder, so builder dot build, and this means we are actually working on the currently pointing that builder object. Okay, so inside that new pizza we are passing the builder object which has all the fields set. Whatever the requirements we have in order to build the pizza, we have inside the builder object, and we have passed this means builder inside this pizza, so that what will happen? So that this constructor pizza will get the builder object with all the desired fields getting its desired values, and it get set all the values inside the pizza class. Okay, because just because this build object, let me clear this, just because this build method is creating a new pizza object with passing the builder object having all the fields pre-filled. Okay, so builder object will fill all the desired fields of this pizza object and will return the object of that pizza. Okay, it will, this builder method, what it will return new pizza. Okay, so what this build method will return, it will return a new pizza, and here this pizza is equals to new pizza. Okay, with all the desired fields that we have set till here, and we got our pizza get ready. Now at the end we are pointing to system.out.println pizza, and with the help of toString the output will get printed whatever requirement or whatever order we have placed in order to get the pizza ready. Okay, so I hope this is clear how the flow is working. So let me go through it once again at a higher level how this is working, and then I'll be pointing to each and every questions and doubts that you all be having in your mind in order to understand this builder pattern very clearly. Okay, let me remove this, let me erase this. Okay, so initially I have this pizza. Okay, I have all the instance method, I have the constructor of this pizza, I have one static method builder which returns me the new builder object. Okay, I have this toString, override toString. Okay, I have this builder class, static builder class. Why using the static builder class? Will be taking it inside the question parts. Okay, I'll be explaining this. Okay, inside this builder pattern, inside this builder class, I have some required fields, some optional fields, a constructor, some methods that will set the desired fields according to the client requirement, and the client code which will actually utilize this builder pattern. Okay, I hope this is clear. Now let me show you some of the internal code. The code internal flow is pizza.builder large. Okay, the stack frame is created and method builder. Okay, we have called this builder method which is inside the pizza class which I have shown you. Okay, method builder pushed into stack. Parameter size is equals to large, so that the size of the pizza will be set as large. We are not actually setting the size of the pizza as large, we are actually setting the builder size is equals to large. Okay, now object creation happens, new builder size happens, allocates the JVM does allocates the memory in heap and creates a builder object. As we have seen, the builder object is created with size is equals to large. Now inside the builder we have all the specific fields. Okay, now the constructor execution, memory now looks for builder object heap. Okay, in this heap we have all the desired fields. Okay, because the builder object have some instance methods, or not methods, instance variables. Okay, now the reference returned temp1, what temp1 is pointing to the builder object in the heap. Okay, just because we have called new builder, so it get into the stack frame, and inside that heap, memory heap, that temp1 will be pointing to the heap. Okay, builder object, that temp1 will be pointing to the builder object in heap. Now as soon as we call on that builder object which is temp, we have called on temp.crushed. Okay, stuffed method called on that same object. This is equal to reference to the existing builder object, whatever builder object that is existing in the heap, we have called that dot crush inside that. Okay, field update, this dot crush is equal to stuffed, return this, no new object created, same reference method. Now temp2 is again pointing to the same builder object. Why? Because inside this crushed, if you'll see inside this crushed, we are again returning this means that builder object. Now temp2 is pointing to that same builder object. Now important insights, until now only one builder object exists. Okay, no pizza object exists yet, we haven't touched any of the pizza object, or any of the pizza object is created till now. Now everything is happening on a mutable temporary object which is the builder. Okay, now whenever or as soon as this dot build is called, now new pizza this, inside this dot build we are returning new pizza this. JVM allocates a new pizza object in heap. Okay, because as soon as we are creating the object, the memory is getting allocated in the heap. Okay, pizza constructor runs, field copy happens just because of this variable, this which is the current object, which is nothing but the builder object which is having all the fields with its desired values. Now field copy happens, this is copying values, not a reference to builder. Okay, pizza object get returned, we have seen now, like inside that build method we are returning new pizza bracket this, so we are actually getting the pizza object, and hence we are ready with our pizza. Okay, now some of the important questions, why return this in every method? Okay, So public builder crust, okay, this crust is equals to crust, return this, as I have already explained, this is equals to current builder object still in memory, sitting in memory, I'm sorry. So to enable method chaining, so as soon as I call this crust stuffed, it returns the same builder object. As soon as I return the cheese, it called this on the same builder object. I call on the pepperoni, it is called on the same builder object. And as soon as I called the build, it is also called on that same builder object. Without using this keyword, I again have to use this. Okay, pizza.builder is equals to new pizza.builder large, and I again have to call builder.crust, builder.cheese, builder.pepperoni, and again in order to call the build, again I have to use builder.build. So some redundant. Okay, so this keyword is useful in this context. Okay, now the most $1,000,000 question is, why public static class builder? Why static? Okay, a most important design decision here. What the static inner class means: a non-static inner class holds a hidden reference to its outer class instance. I am repeating it again. A non-static inner class, let's say there is a class inside a class which is not static. Okay, so a class A and a class B. Okay, so a non-static inner class always holds a hidden reference to its outer class. This B always holds a hidden reference to its outer class. Means you would need a pizza. Let's say for our example, what we have done, we have declared a pizza. Okay, pizza. Inside this pizza, we have a builder. Okay, if we haven't declared this builder as static, then with this line holds a hidden reference, that means that builder must hold a hidden reference of this pizza. So means you would need a pizza object first. Okay, in order to build that pizza, I need a pizza object first, because this builder holds the hidden reference of this pizza to create a builder. Again repeating, I need a pizza object first in order to create the builder. Okay, I hope this is clear, which defeats the entire purpose. If builder was non-static, which is bad, again I need to do pizza is equal to new pizza. I have to create the pizza object first, then I need to call the builder object, which again break the whole pattern. Okay, so you are trying to build the pizza, it doesn't exist yet. In this line, I am trying to build the pizza, it doesn't exist yet. You can't need it before building it. Okay, with static, no outer instance needed. This is the main important part of declaring the builder as static. If it is a static class, then there is no outer instance needed in order to create the builder. Okay, so static inner class, which is the correct. Now what we are doing, static here means this builder class belongs to the pizza class conceptually, but doesn't require or doesn't need pizza instance to exist in order to build that pizza first. Okay, so I hope this is clear. So I hope I am able to explain this pattern a little bit clearly. Okay, so now that is it for the video. If you all have any doubt, you all can comment inside the comment section, and next pattern I'll be uploading soon. So thank you for watching and having patience. So thank you.